Dear students, welcome to Divya's Math Solutions. Today we are going to discuss Chapter 6 Application of Derivatives, Exercise 6.2. Question number 7. Show that y equal to log of 1 plus x minus 2x by 2 plus x greater than minus 1 is an increasing function of x throughout its domain. So we need to show that the function is increasing. That means what we need to check? We need to check the first derivative of function. If it is greater than 0 means what we can conclude? The function is increasing throughout its domain. So what is the value is given? Y equal to log of 1 plus x minus 2x by 2 plus x. Next we are going to find the first derivative. That means dy by dx. Derivative differentiating with respect to x. So we can write as dy by dx. Here also we need to write the derivative. So dy by dx of log 1 plus x minus d by dx of this one 2x by 2 plus x. So derivative of log x is 1 by x, correct. So 1 by 1 plus x, then derivative of x is 1 only. No need to write. D by dx of 2x by 2 plus x. This is in the form of d by dx of u by b, right? So things in the denominator, that means 2 plus x into derivative of numerator. Derivative of numerator means derivative of 2x is 2 minus the function in the numerator, that is 2x into derivative of denominator. Derivative of denominator is d by dx of 2 plus x. That means derivative of x is 1. 2 is 0 plus 1 is 0. Divided by the thing in the denominator, the whole square. That means 2 plus x, the whole square we can write. This is the whole thing in bracket. So 1 by 1 plus x minus this bracket we can open. So this become 2 into 2 is 4 plus 2x minus 2x the whole divided by 2 plus x the whole square. This plus 2x minus 2x cancel. Now we can take the LCM. So LCM is 1 plus x into 2 plus x the whole square, right? So we can cross multiply. It means what we will get? 2 plus x the whole square minus 4 into 1 plus x the whole divided by 1 plus x into 2 plus x the whole square. So the numerator also we can rearrange. So dy by dx equal to, this is in the form of a plus b the whole square. That means 2 square is 4. 2ab means 2 into 2 is 4. 4x plus x square minus 4 minus x divided by 1 plus x into 2 plus x the whole square. So this plus 4 minus 4 cancel. So we will get dy by dx equal to x square. 4x minus x is 3x, right? So here also 4 into 1 is 4. 4 into x is 4x. So this plus 4x minus 4x cancel. So what we will get? X square by 1 plus x into 2 plus x square. This is the first derivative. Now we are going to verify this function dy by dx is greater than 0 or not. So here we can see that x square. For negative value also x square is always greater than 0 only, right? So this x square is greater than 0 we can write. And this 2 plus x square, that is also greater than 2 plus x the whole square. That is also greater than 0, correct? As these are, why? Because these are squares only, right? If you are taking square means negative value also you will get positive answer only. Then which one is remaining? This 1 plus x. Is 1 plus x is, if it which one? This x value is given as x value greater than minus 1. Greater than minus 1 means what are the value? 0, 1, 2, 3 like that only. That means this x plus 1 also you will get greater than 0 only. These are squares. These are perfect squares we can write. Then 1 plus x is also greater than 0. Why? This given as this x greater than minus 1. So x greater than minus 1 means this 1 plus x also greater than 0. So everything is greater than 0 means what we can write? Therefore we can write dy by dx. The first derivative is also greater than 0 if x greater than minus 1. So the function is strictly increasing throughout the function we can write. Therefore hence we can write Hence, function of x strictly increasing or increasing throughout its domain. Throughout its domain. Hence, proved we can write. Question number 8. Find the value of x for which y equal to x into x minus 2 the whole square is an increasing function. So this given us, this is an increasing function. So we need to find the value of x. So what is the given function? Y equal to x into x minus 2 the whole square. So first we can find the first derivative of this function. That means dy by dx. Dy by dx means derivative of this function we need to write. Derivative of this one means this is in the form of x raised to n. N into x raised to n minus 1, right? That means 2 into x minus 2 we can write. This is the first one. 2x form. Next we need to write the derivative of this function. This is x square is over. Next we need to write dy by dx of what is remaining? X into x minus 2 is remaining. So 2 into, in bracket, x into x minus 2. Then derivative of this function. Correct. So derivative of this x square. This x square means how we can write? Derivative of x square is 2x we can write. Then this open the bracket means 2x means what we can write? 2 also we can write. So I am just writing d by dx. So first we can open the bracket. After that we can write the derivative. X into x is x square minus 2x. Next step we can write the derivative. That means 2 into x minus 2. Derivative of x square is 2x minus 2 into derivative of x is 1. 2x minus 2. Correct. So the answer we will get 2 into x minus 2, 2x minus 2. This is the which one derivative. So from here we can take 1 2 common means what we can write? 2 into x minus 2, 2 into x minus 1. So the 2 we are multiplying means 4 we can write. Correct. 4 into x minus 2 into x minus 1. This is the derivative of this function. So next we need, this is the first derivative. So here it is given the function is increasing also. This is an increasing function. We need to find the value of x. So the condition is we are going to find the value of x. How we can find? If f of x equal to 0 means we can find the value of x, right? If f dash x, that means if dy by dx equal to 0 we are taking for finding the value of x. So how we can write? 4 into x minus 2 into x minus 1 equal to 0. That means what we can write? X equal to 0 or x minus 2 equal to 0 or x minus 1 equal to 0. So the value of x equal to 0 or x equal to 2 or x equal to 1. That means we will get the value of x as 0, 1 and 2. That means we can write the interval. Correct. So how we will write the interval? Minus infinity to infinity only will write the interval. So here will 0, 1 and 2 is there. So minus infinity to 0, 0 to 1, 1 to 2, 2 to infinity. So like this we will get the integral. Correct. So this 1 to 1 divide the number line into 4 intervals. So each one we need to check. So this interval and the value we can check. So suppose like a column we can write. The interval we can take it as minus infinity to 0, 0 to 1, 1 to 2, 2 to infinity. These are the intervals. Okay. These are the intervals. Next we are going to find the sign of this dy by dx. Correct. Sign of dy by dx. Then how we can consider this one? Based on the nature of this function we can find the this function is increasing or decreasing we can find out. The sign means minus infinity to 0 means what we will consider? We will consider only negative values, right? So here it is 4 into negative value means first one is minus. This is minus. Minus means what we will get? Minus we will get. Here also minus 1 means we will get minus value, right? So minus plus into minus only. That means the value is less than 0. Less than 0 means what we can conclude? The function is decreasing. The function is decreasing only, right? Next, sorry, this is minus infinity to 0. Minus infinity to 0. So 0 to 1 I will write over here. 0 to 1. Next integral is 0 to 1. 0 to 1 means we will consider positive value in between 0 and 1. That means 0.5, 0.6, 0.7 like that only. Anyway, positive means what? This x is positive only. Next, we will consider the value as in between 0 and 1. That means suppose I am taking 0.8 means what we will get here? 0.8 minus 0.2 means what we will get? Negative value. Negative. Here also 0.8 minus 1 means 1 is a bigger number, right? So we will get negative. So minus minus plus plus. That means the function is greater than 0 means the function is increasing. Correct. This is a nature. Nature of y. The function. Function is y only, right? Nature of y is function is increasing. Next integral is 1 to 2. 1 to 2 means we can take 1.5, 1.6, 1.3 like that we can take. So anyway, that is positive means the first one is plus. Next 1.2, 1.3 up to 1.9 only we can take, right? That means here what we will get? Minus value because 2 is a bigger number. 1.5, 1.6 means that is the bigger one. So here we will get positive value, correct? So plus minus minus, that is less than 0 means the function is decreasing. Next 2 to infinity. 2 to infinity means 3, 4, 5, 6 any value we can take. So x is positive only. 3 means 3 minus 2 is 1, that is positive. Next 3 minus 1 is 2, that is also positive. So the function is greater than 0, that means function is increasing. So for the function is where the function is increasing? The function is increasing on 2 to infinity and 0 to 1. Here we need to find the value of x for which the function is an increasing function. Here they are given the function is an increasing function. So increasing on which interval? 0 to 1 and 2 to infinity. So the function is increasing on, therefore function is increasing on 0 to 1 and 2 to infinity. 0 to 1 and 2 to infinity. So we need to write the value of x means what? We need to take union of these two. 0 to 1 union 2 to infinity we can write because the value of x means. Question number 9. Prove that y equal to 4 sin theta by 2 plus cos theta minus theta is an increasing function theta in closed interval 0 to pi by 2. In this interval the function is an increasing function we need to prove. That means dy by dx is greater than 0 we need to prove, right? So the value of y equal to 4 sin theta by 2 plus cos theta minus theta. First derivative means dy by dx. This is in the form of division. Division means d by dx of uv form, right? That means how we can write? V into derivative of u minus u into derivative of v the whole divided by v square, right? So that thing in the denominator, that means 2 plus cos theta into derivative of 4 sin theta. That means 4 into derivative of sin theta is cos theta minus 4 sin theta into derivative of 2 plus cos theta. So the derivative of 2 is 0 only. Next derivative of cos theta is minus sin theta. 0 minus sin theta we can write the whole divided by 2 plus cos theta the whole square minus derivative of theta. Derivative of theta is what? 1 only. Here it is d by d theta because the function is not in terms of x, in terms of theta only. So we are differentiating with respect to theta. So dy by d theta, the numerator we can open the bracket and write 4 into 2 is 8 cos theta plus 4 cos square theta. This is 0 only, minus into minus plus 4 sin square theta minus cross multiply means what will happen? 2 plus cos theta the whole square the whole divided by 2 plus cos theta the whole square we can write. So this one, if we are taking 4 common means what is this one? Cos square theta plus sin square theta is 1 only, right? So this one we can write it as 8 cos theta. Taking 4 common means sin square theta plus cos square theta minus this one, a plus b the whole square. 2 square is 4 plus 2ab. 2 into 2 is 4 cos theta plus cos square theta the whole divided by 2 plus cos theta the whole square. So this become 8 cos theta plus 4 into sin square theta plus cos square theta is 1. Open the bracket means minus 4 cos theta minus cos square theta. Minus cos square theta we can write. Next, divide by 2 plus cos theta the whole square plus 4 minus 4 cancel. So 8 cos theta minus 4 cos theta is 4 cos theta. 4 cos theta minus cos square theta divided by 2 plus cos theta the whole square. So again we can take cos theta is common from the numerator. So what is remaining? Cos theta into 4 minus cos theta divided by 2 plus cos theta the whole square. This is dy by d theta. This is the value of dy by d theta. So here only we are going to prove that the function is strictly increasing. Strictly increasing means what we need to prove? Dy by d theta greater than 0. So one by one we can check this one. First one is 2 plus cos theta the whole square. The whole square means a square means what we will get? Always we will get a positive value, right? So we can write, here we can write 2 plus cos theta the whole square greater than 0. Reason, it is a square number. It is square, right? Because it is a square or it is a perfect square we can write. Next, cos theta. Cos theta value we can check. Cos theta value, in which interval we need to check theta value? 0 to pi by 2. So cos value between 0 and pi by 2 we can say that the values are 1 root 3 by 2, 1 by root 2, 1 by 2 and 0. That means all greater than 0 only, right? So what we can write? Cos theta greater than 0 as theta in the interval, closed interval 0 to pi by 2. Correct. So this theta value is greater than 0 only. Next, 4 minus cos theta we need to check. So what are the values of cos theta? One is cos 0 is 1. That means 4 minus 1 is 3. That is positive only. Next, root 3 by 2. That means 4 minus root 3 by 2 means we will get positive value. Next, 45 is 1 by root 2. That is also will get positive value. 4 minus 1 by 2 also will get positive value, and cos 4 minus 0 also will get positive value. That means 0 to pi by 2, each number we are substituting means, cos value we are substituting means we will get positive value only, right? That means 4 minus cos theta is also greater than 0 for this theta is belongs to which value? 0 to pi by 2 value. So what we can write? Therefore we can write dy by d theta greater than 0 for theta belongs to 0 to pi by 2. So what we can conclude? Therefore function y is strictly increasing. Thus function y is increasing function of theta in 0 to pi by 2. Hence proved we can write. Question number 10. Prove that logarithmic function is strictly increasing on 0 to infinity. So logarithmic function means how we can take the function? Log x only, right? F of x equal to log x we can write. First derivative means f dash x only. F dash x is equal to 1 by x. F dash x is 1 by x. 0 to infinity. 0 to infinity means what are the values we are considering? Only positive values. So for all the positive values, the function is greater than 0 only. So from here what we can write? From here we can write f dash x is greater than 0 for all x belongs to 0 to infinity. So what we can write? Therefore logarithmic function is strictly increasing on 0 to infinity we can write. Okay. Question number 11. Prove that the function f is given by f of x equal to x square minus x plus 1 is neither strictly increasing strictly decreasing on minus 1 to 1. Neither this is not increasing also, not decreasing also, we need to prove. So first one we can write the function f of x equal to x square minus x plus 1. First we need to write the first derivative of the function. So f dash x equal to derivative of x square is 2x minus derivative of x is 1, derivative of 1 is 0 only, right? So f dash x is 2x minus 1. So next we are going to find the value of x. That means what we need to write? If f dash x equal to 0, so what we can write? 2x minus 1 equal to 0. That means 2x equal to 1. So we can write x equal to 1 by 2. 1 by 2 means minus infinity to infinity only the interval is coming. Here we are taking minus 1 to 1. So minus 1 to 1 by 2, 1 by 2 to 1 the interval, right? So the interval is we can write it as minus 1 to 1 by 2 and 1 by 2 to 1. The interval is given. Next we need to check for the values. This two intervals we need to check. So f dash x equal to, what is the value of f dash x we got? F dash x is 2x minus 1. If 2x minus 1, see minus 1 by 2 to minus 1 to 1 by 2. 1 by 2 means 0.5, right? So minus 1 to 0.5 means what we will get positive, this minus values and some positive values also will get, right? So 2x minus, so this minus 0.9 means we will get minus value. Then here we are taking 0.4 means 0.8. That means here also we will get negative value. That means minus 0.9. Suppose we are taking minus 0.9 means what we will get? Minus 0.9 into 2 is minus 0.18. Minus means minus answer we will get. Next till 0.5. 1 by 2 means 0.5. So below that which number? 0.4 I am taking. 0.4 into 2 is 0.8. 0.8 minus 1 means what we will get? Minus value we will get. That means f dash x is less than 0 for which one? Less than 0 for all x belongs to which one? Minus 1 to 1 by 2 interval. So less than 0 means what we can write? The function is strictly decreasing. Therefore, function is strictly decreasing on minus 1 to 1 by 2. The function is strictly decreasing on minus 1 to 1 by 2. Next f dash x, next interval we can check. F dash x is 2x minus 1. 1 by 2 to 1. 1 by 2 to 1 means what? 0.5 to 1. That means 0.6, 0.7, 0.8 like that only, right? Suppose I am taking 0.6. 0.6 into 2 is 1.2. 1.2 minus 1 is greater than 0 only. 0.7 we are taking means 1.4 minus 1, that is also greater than 0. Correct. So the function is greater than 0 for all x belongs to 1 by 2 to 1. That means what we can write? Greater than 0 means function is strictly increasing. Therefore, function is strictly increasing on 1 by 2 to 1. That means the same function 2x minus 1 is increasing also, decreasing also. So that is not possible. Either the function should increase or decrease, right? Both are not possible between the interval minus 1 to 1. So what we can write? Therefore, the function is neither increasing nor decreasing on minus 1 to 1. Therefore, we can write, hence we can write the function f of x is neither increasing nor decreasing, neither increasing or nor decreasing on minus 1 to 1. Question number 12. Which of the following functions are strictly decreasing on 0 to pi by 2? We need to check one by one. First one, cos x. That means we can take f of x equal to cos x. Next we need to write the first derivative. That means f dash x equal to derivative of cos x is minus sin x, right? So the interval is 0 to pi by 2. If you are taking 0 to pi by 2 value, we can see that the sign values between 0 and pi by 2, everything is positive only, right? But here one minus symbol is here means what will happen? The value is less than 0 only. That means minus x less than 0 for all x belongs to 0 to pi by 2. 0 to pi by 2 values are positive, but this minus the sign, the value is less than 0. If it is less than 0 means what we can write? The function is strictly decreasing. F dash x is less than 0. Therefore, the function is strictly decreasing. The function is strictly decreasing on 0 to pi by 2 we can conclude. Next, second one, cos 2x. So we can take f of x equal to cos 2x. Next we can take the first derivative, that means f dash x equal to derivative of cos 2x is minus sin 2x into derivative of 2x. 2 is a constant and derivative of x is 1. So f dash x equal to what we can write? Minus 2 sin 2x. So f dash x equal to, we got minus 2 sin 2x and the interval is given as 0 to pi by 2, right? That means x belongs to which interval? X belongs to 0 to pi by 2. Here what is the angle? 2x is the angle, right? So first we can write, if x belongs to 0 to pi by 2. If x belongs to 0 to pi by 2 means what is the value of 2x belongs to? Then we can write 2x belongs to 2 into 0 is 0 only. 2 into pi by 2 means 2 cancel. What is the value we will get? 0 to pi value we will get, right? So 0 to pi value we need to consider. For this function we are going to consider the values of 0 to pi, because here the angle is not x. Here the angle is 2x. But sin 2x. Sin 2x is greater than 0 when if 2x is belongs to 0 to pi means what we can write? The value, if we are taking the values from 0 to pi, that means 0 to 180 also, the values are positive only, right? So the sin 2x value is greater than 0. Only sin 2x. Sin 2x value is greater than 0. Which one? If x belongs to 0 to pi. So this is greater than 0 means this is also positive only, but here one by default one minus is there. So what we can write? The f dash x is less than 0 only, right? So here f dash x equal to minus 2 sin 2x. The sin 2x value is greater than 0 only. Because of this minus, what will happen? This become less than 0, right? So what we can write? Less than 0 if 2x belongs to 0 to pi. So what we can conclude? The function is strictly decreasing on 0 to pi by 2 we can write. Therefore, function is strictly decreasing on 0 to pi by 2 we can conclude. Next, C. Cos 3x. This one we can take it as f of x. So first derivative we need to write, that means f dash x. F dash x equal to derivative of cos x is minus sin x, then derivative of 3x is 3 only, right? So minus 3 sin 3x is the answer, correct? So here also this x belongs to 0 to pi by 2. Here the angle is not x, 3x is the angle. So based on that we need to write here, if x belongs to 0 to pi by 2, then what is the value of 3x belongs to? 3x belongs to 3 into 0 is 0. 3 into pi by 2 is what we can write? 3 pi by 2 we can write. So the value here we are going to consider is 0 to 3 pi by 2, correct? But the sin 3x value, the sin 3x value for 0 to 3 pi by 2 means this pi by 2 is what? 90 only, right? So 90 into that is 270. Between 0 to 270 we can see that the sign values are positive only, right? So what we need to write? The sin 3x is greater than 0, but this sin 3x is greater than 0 for 3x belongs to 0 to 3 pi by 2. Still 0 to 3 pi by 2, the sin x value is greater than 0 only, right? 3 by 2, 0 to pi. Only we are taking 0 to pi only. 0 to still 0 to pi. That means 0 to this one 30 degree, 45 degree, like that we are taking means still 0 to pi, the sin value is greater than 0 only. So after that, if sin value is less than 0, this is less than 0 for which one? Next interval, that means till 0 to 3 pi by 2 we need to check. Here till to 0 to pi the sin value is greater than 0. So this is greater than 0. Then what about this minus 3 sin 3x, that is less than 0 also, right? So less than 0 for which one? If 3x belongs to 0 to pi, or x belongs to this pi by 3 also, pi by 2 also we need to consider, correct? Next, sin 3x is less than 0 for this 3x belongs to this till where we consider 0 to pi. Next pi to 3 pi by 2. Pi to 3 pi by 2 value, the sin 3x value is less than 0 only. This is less than 0 means minus. So here we are substituting means what will happen? F dash x is greater than 0. So here in the two cases, in the first case sin 3x greater than 0 for 0 to pi. So here also what we will get greater than 0 means what we will get? F dash x. Substituting in F dash x means that we will get less than 0 for all x belongs to 0 to pi. Next here this one we can substitute. Sin 3x less than 0, that means minus value. So minus minus plus, right? So there we will get f dash x equal to greater than 0 for all x belongs to pi to 3 by 2. That means two conditions are there. In one interval the function is increasing, in another interval the function is decreasing. So what we can conclude? In between the interval 0 to 3 pi by 2 or the given interval 0 to pi by 2 we are considering means what will happen? The function is neither increasing nor decreasing, we can write. Hence function is neither increasing nor decreasing on 0 to pi by 2 we can conclude. Next D. D is tan x. So f of x equal to tan x we can write. F of x is tan x. This tan x, how we can write derivative of tan x? That means f dash x. Derivative of tan x is secant square x. Here the value is in terms of x only. That means what is the value is given? 0 to pi by 2. No need to convert on these two like these two questions. Directly we can check. So the secant square x is greater than 0 for 0 to pi by 2. We know that one, right? So what we can write? This one is f dash x is greater than 0 for all x belongs to 0 to pi by 2. So what we can write? The function is strictly increasing. Therefore, the function is strictly increasing on 0 to pi by 2. So what we need to find out? Which of the following functions are strictly decreasing? So what are the functions are decreasing? A and B is decreasing. This C is neither decreasing nor decreasing. D is increasing. So which one is decreasing? The final answer we can write it as A and B. Option A and B are which one? Decreasing on the interval 0 to pi by 2 we can write.